There is plenty of cool stuff in 19, and the crowd updates might not be the first that comes to mind. They are still pretty useful though, and I'm gonna walk you through my favorites. Before I do that, I just want to mention two short ones, and that is that blend shapes are supported by the viewport, like you can see here, and that you also have X-ray support for the agent configure joint stop. Very happy about that. Anyways, the two main topics for today is a new layer system for agents, and I will also talk about the new metadata support in the agent definition. Alright, let's get into it. '19 comes with a fancy new layer system for crowd agents, but before we get into how that works, let's get back to 18.5 and see how it used to work. I have this character, and in here I have these different geometry shapes. Let's make an agent out of him. So I'm going to go in here, just point to him. So here is our agent. And the next step would be to set up different prop variations. The old way of doing that was to have one layer for each configuration. So I would do agent layer. Let's do one without anything. So I would just go in here and I would just set this to skin. So now we have him without anything. And then I would have another one. And on this one, I also want to have, let's call this hat. And here I would add the hat. And then I would have another one. And this would be the beanie layer. A lot of time this is good enough, but as soon as you try to combine different things, you can see it's going to get complex quite soon. So for example, say that I want to have sunglasses on half of them. I would have to make first like a beanie one with sunglasses, and then I would have to make a hat one with sunglasses, and then I would have to have like a main one with sunglasses. So instead of just adding the sunglasses once, I have to add them 3 times. And you can see exponentially, this is just going to grow. So the more combinations you have, the more complex it's going to be. And this could be quite a headache sometimes. But luckily, this is not a problem anymore, because now in 19 we can stack layers. So let's go into 19 and see how that works. So I'm going to go in here in 19. And we have the same guy out here. So I'm going to do agent. Let's get him in here. So here he is, and let's drop down the new agent layers up. So here we go. It looks a bit different, and now you can see that we can add more than one layer in the same SOP. So let's start by just having the main body. So I'm going to go here, and I'm going to call this first main body. And then I'm going to go to use existing shapes. Let's go sources from default, and then I'm going to filter shapes. So I'm just going to have the skin here. I'm going to take away that star. So now that is the first layer, and then I'm going to add one for the beanie. And the same thing there. I'm going to go into default, and I'm going to add a beanie. Now you can see both of them. And that is just because set current layers, you see it is set to star. That means it takes every layer on that agent and just combines them. But you can also solo the different layers. You can see we solo the main body, which is just the main body, and we can solo the beanie. And then we just have that. And let's continue. So I'm going to add the hat down here. Let's have a hat layer. Same thing here. Gonna filter that by, filter that by hat, and now we have a hat layer. And finally, let's add the sunglasses. And same thing here, go into default and shape and put that to, sunglasses. And that is that. Cool. And now if we want to try out our layers, we can actually do it on this node if we want to combine it up here, but let's just go and drop down an agent edit. In here, you can set the current layers. So let's start by setting the main body. Now we just have the main body, but then we can add to this. So we can say add main body and hat. So we have main body, hat, and now the sunglasses. Cool. This is obviously very handy. And let's just see how we would do that on a full crowd. So I'm gonna move this to the side, drop down a crowd source. And now suddenly we have a bunch of guys. And now I want to randomly assign stuff to them. Now we can use this new node, crowd assign layers. So let's drop that down and connect that up here. And first of all, remove layers is an option here. So I'm going to do that. And then I'm just going to add the main body. So now all of them have the main body. So you can see I can add different pools here. And then you have like a sub selection. So in this first selection, I want everyone to have that body. It could be that maybe you have like 2 different main bodies. Then you could add both here and have them vary. But for us, we just need one. And then we're going to add a second pool. And in this pool, we're going to have all the hats. So let's first start with the hat. So now all of them have hats, but let's add the beanie as well. So you can see some of them have hats and some have beanies. And we have like these weight values. We can drive it with that. But maybe you don't want all of them to have hats. That's easy enough. We can just add an empty layer. So I'm going to go up here. I'm going to go down. I'm going to call this empty. And then we can go down here again and add that and set empty. And now there will be some of them that don't have hats. That is cool. Okay, and now if I want half of them to have sunglasses, I can just add that like this. So I go sunglasses and empty. And that's that. So now you can see some of them have sunglasses, some of them don't, and it's like all kinds of different variations. So obviously this is a much nicer way of setting up variations in crowds. There's also different ways of setting up crowd layers. So let's have a look at the second way of doing it. You can also add the layers procedurally. So let's have a look at how we can do that. So in this example, I have this guy and it's just a skin. And then I have all the geometry. It's just like through these file nodes. And what I've done is that I've used a merge one. And then I have this transform. So I just use that to place them roughly relatively to this bind pose up here. And then I've done that for all 3. And so I know they are in the right place relative to this one. And now I just want to add them as layers. So then you can drop down the agent layer again. And you can see we have 3 different inputs. And the second input lets us put in shape geometry. And that's what we want to do right now. The shape geometry that is expecting is pack primitives. So let's first pack all these guys. So I go merge packed. So now it's just merge them and pack them. And you also add this name attribute. So if we look in the spreadsheet, you can see on each primitive we have a name. Now it's color 1, color 2, color 3, and that is just because by default it just picks up the last node names here. But you can of course change them. So I'm going to change them to sunglasses and hat and beanie. Cool, that's better. And now if we connect this here, you can see this little section here suddenly gets active. And you can see shapes, and then it's asked for a name attribute, and that is name, which is the same we have on this one. And that means that these are now added as shapes. So you can see that here, if you want to do layers the old way, you can add the layers here and combine them and make a layer out of that. But we want to have it more procedurally, so I'm actually going to turn that off. I'm going to check this layer name attribute, and I'm going to change this to name as well. So that means for each name here, for each shape name, it's also going to create a layer. And we can see that if we go to agent edit. And then we can set default, which is from this agent here. But we can also add the other ones. You can see we have the hat and we have the sunglasses, for example. Cool. Okay, that's good. But we're not finished yet. Because if we would do an agent clip here, and then we're going to get another clip like this run clip here. It's going to clamp that to 17. and then call that run. And also I want to strip out the motion, convert like that, and then let's have a look at the clip. So do run. You can see it's not actually attached to anything, and we want it to be attached to the head. So when we can do that, we can tell it to be attached to the head joint. Let's go back to the agent layer SOP, and under shape bindings, we can go to transform names and select head to head end. But something happens that we didn't want to happen. You can see that we get this tiny hat here because it's converted to that coordinate space of that joint, and that is not what we want. So in the old agent layer SOP, there was an option. You could check this checkbox to keep the relative position, but we don't have that, not yet anyway. So maybe that will come later. But for now, we kind of need to do that operation ourselves. But it's not super hard. You just need to write a little bit of vex. So let's do that. So I'm going to drop down a wrangle, connect that here, and then I'm going to connect that to this guy up here. Because as you remember, these are placed correctly according to this pose up here. All right, so let's see. Convert coordinate. All right, so what do we need then? So first I need to find the joint ID of that joint that we're going to attach to. So we do that by int head ID, agent rig find. I'm going to do 1 because it's connected to the second port. I'm going to have it on 0 because it's just one agent. And then I need to have the name of the joint we're looking for. So let's just copy this name here, copy, and then paste that in here. So now we have that ID. Now we want to have the matrix of that transform. So let's do a matrix, head, and then we do agent, world, transform, 1, 0 again, and then we can use that head ID. Cool. So now we have the matrix for that head. And now what we need to do, we want to get the matrix of each of these guys, and then we want to multiply that with the inverse of this. And because these are packed, they have a packed transform. So let's get that transform. So matrix X form, get packed. And now we'll have that X form. Let's multiply that with inverse. And then we do head X form. And then we set the packed transform again. Set packed transform. And boom, there it is. And you can see here, by the way, that this, it changes the transform, and now relatively to that joint, it's going to be correct. So now everything is working as it should. Cool. And by the way, here's another thing to keep your eye on. You can see you have like this little warning. Let's say the shape geometry is time dependent, and that is actually a common performance issue. So it's just now everything gets evaluated on each frame, so you obviously don't want that. So just have the time shift at the end of this, and then persist to F start. So now that's gone. Now it's not going to move in the animation clips, so then you need to go to the agent edit and set the clip time to $t, and now you have the movement again. Cool. All right, so that is how you procedurally set that up. Let's now finish this up by looking how all this ties into Vellum. Okay, so let's try out some Vellum. And here it's basically the previous scenes. I've just added a crowd source, and I also assigned the layers, so I don't have to do that again. And what I want to do is I want to add a party hat to these guys. So I have this little thing. I want that to be a layer, but I also want to simulate that with Vellum. So the way to do that is to, first of all, I'm going to set up some Vellum constraints. So I'm going to have Vellum configure cloth, like so. I want to attach this to the head of the agent, so I'm also going to unpack this. And I'm going to connect that into the geometry port here. And then I'm going to have an attach, Vellum attached to geometry, like so. And now everything is attached, and I don't want that. I just want the bottom parts to do a max distance. Maybe something like that. Yeah, so now it's attached to the head. And let's just see how the cloth looks. I'm going to drop down a Vellum solver. And let's just try it out. So it's a bit stiff for my taste. So I'm going to go and change that. So for the bend stiffness, I'm going to set this to something like that. Let's try it again. Yeah, that's better. So let's go with this. I mean, it's still not amazing, but that's not really the point. So I can delete this Vellum solver now, and now I just want to pack this, just like I packed all the stuff over here into pack primitives. I want to pack all this Vellum stuff into a primitive as well. So we can do that with a Vellum pack. So let's connect that here. So now we are packing it, and you can see we can have this checkbox and the name just like over here. So let's just call this party hat. There you go. And now I want to attach that. So I want to procedurally generate it based on this name. So I can just add a merge up here. I apologize for my spaghetti move I'm going to do here, but I'm going to drag it up here. So now by doing that, we're going to add that layer to this as well. So if I go down to this crowd design, I will be able to add a party hat. Party hat. So some of them will have that. Cool. All right. Let's give it a color as well. Okay, so now we have these party hats. Because I want it to be faster, I'm going to have less party hats. I'm going to have it to 0.5, so I just have a few, maybe even less than that. So, like that. Okay, so there we have 2 hats, and I want to simulate them. But first, let's make a crowd sim here of this. So I'm going to do a .NET. I'm going to connect this, and then I'm going to have a crowd solver. And then I'm going to have a crowd object. For this crowd object, I'm going to have the first context geometry. And then I'm going to have a state. And I'm going to call this run. And then I'm going to have, let's go to the start so I can see what clips I have. I'm going to use the run clip. And I already set up for the crowd source. So the crowd source is using run as the initial state. So yes, that's cool. Oh, actually, we're going to go and change this to locomotive as well. So let's see, do we have a crowd sim now? So go down here and then we play it. Yes, we have a crowd sim. Perfect. Cool. All right. So that's the crowd simulation. Now we just need to get the hats and simulate them as well. And then we're going to merge that back to the crowd. So now we can use the new agent Vellum unpack. And there are some nice new features. Like, for example, we have this additional port here that is quite useful. I'm going to show that in just a minute. But for now, let's first select the layers we want to simulate. And we want to have the party hat and not this stuff. And now we can see we're just going to get the hats. Cool. I also want to have a pre-roll. The Vellum simulation should start on frame 1. And then we want the crowd to be shifted to however long we want the pre-roll to be. So we're going to do a start frame plus 25. That's how long we want the pre-roll to be. And then as a rest clip, let's have this rest clip here. And then we can drop down a Vellum solver. And if we look there, now we're going to see the pre-roll. So you can see they are moving from the rest post, getting into position, and then at frame 25 they will start running. You can also see that the party hat is wobbling and being simulated. Sweet, all right, so that's that. It's not the best simulation, but it will do for this. So we have that. You can see we have, if I take a null out of this, just going to see the hats. And then we will merge that with the rest of the crowd. We also want that crowd to not have the party hats. Otherwise, we'll have double geometry. And then you would have to shift the start frame of the crowd sim to compensate for the pre-roll. Now this new port comes in handy because that does all that for us. So we can just do a merge here. Connect these two, and look at that. So it's going to be frozen until our pre-roll is over, and then it's going to get going. So yeah, so that is how you would add some Vellum into the new layer system. So you see everything works perfectly together. Cool. Right. So last thing I want to show you is that you can now save metadata to the agent definition. And if you're working in a big studio with a complex pipeline, you probably know why this is good already, and you have to extract all kinds of things from a pipeline all the time. But even if you're not, it can be really useful because you can save anything in this metadata. So I'm going to show you a very simple example when I set up a scale interval. I have this agent here. I'm going to drop down an agent metadata. And the metadata would be a dictionary. So you have a key and then you have a value. So I'm going to start here with a min, and this will be the smallest an agent can be. And then I'm going to have another key that would be a max, and this will be the biggest an agent can be. So by doing that, we have added this dictionary to the intrinsics. We have agent metadata. You can see in here we have max and min. Sweet. Okay. Let's save this out as our agent definition. Oh, I didn't mean to. Agent definition cache. Like so. And I'm going to call this meta agent. I'm going to save that. And then I'm going to load it. And nowadays you get these icons. You can see that you are loading it from disk. And then let's set up the crowd. I have a crowd source. Like so. And let's have this clip. I'm going to randomize the time. So here we have it, our little crowd. And now we're going to apply this rule. So I'm going to have a wrangle. And the first thing we need to do is to get the dictionary. So then you use this type, dict. And we call it metadata. And then we use this function, agent metadata. Right, so now we have the dictionary. And now we're just going to extract the values. So let's have the min value. Because all the data in the dictionary are strings, we need to convert it. So I'm going to do atof. And then I'm going to have metadata. And then we call min. And then we have a max as well. So we have a min. Oh, wait, I didn't spell it. I call it metadata. Let's go metadata. Metadata. All right. So here we have min and max. And now I'm just going to use this to randomize the scale. So I'm going to have that p scale. It's 0, 1. Rand at ptnum min and max. So here you go. Now we are using whatever we have in that metadata. And let's do another one. I'm going to drop down an agent here and read that cache. So agent definition cache. It was like meta agent. So now we're getting that back. And let's do another crowd. Going to be similar, but I'm just going to change the number. And do this to 30. So you have this new crowd. I also want to save it. So I'm going to cache that out. And then let's just cache it like that. And then after this, I'm going to add this wrangle again. So of course here it's going to be the same. Maybe not that surprising. The cool thing though is that because this is on the agent definition and this file cache is reading the agent definition, it's referencing the agent definition on disk. And that means that you can go to the metadata here, we change it to something else. And then we can save it again. And then you can reload this file cache. And now you can see it picked up that change. Obviously, there's a lot of things you can do with this. This is a super simple example, so maybe not that exciting, but hopefully this will give you some ideas. And this is the end. As a summary, maybe not the fanciest, most eye-catching features, but nevertheless pretty cool. I hope that you found this all useful, and see you next time.